Hey, this is the Blink Labs closeout video for our Handshake decentralized DNS blockchain integration with cDNSd by Blink Labs. This project connects Handshake blockchain name data to Cardano DNS tooling so developers can use decentralized DNS data through practical, production oriented open source components. We entered the Cardano Open Developers Challenge because it was a natural fit for Blink Labs. We are open source devs with a heavy background in infrastructure, and the challenge aligned directly with our own goal of improving the developer experience on Cardano. Our proposal was to build a practical integration between the Handshake decentralized DNS blockchain and our Cardano DNS tooling, especially cDNSd, so developers could work with blockchain-based DNS data through clear, reusable components. So technically, we proposed a three-part solution. The first part was to parse and validate Handshake blockchain data. The second, to add live network communication and block streaming from Handshake nodes. And the third was to integrate that data into cDNSd and serve it through DNS. This approach focused on turning raw blockchain data into usable developer services with open source code and documentation that others can run, extend, and build on. So the proposal was funded for 130,500 ADA. Once funded, we progressed in the same sequence we said in our proposal and milestone plan. So milestone 1, we delivered parsing and validation of Handshake blockchain data. Milestone 2, we delivered Handshake node communication and continuous block streaming. And milestone 3, we delivered integration into cDNSd and DNS serving, completing the end-to-end pipeline from chain data to usable DNS responses. So we stayed within the original tech scope, but we did submit a change request for timeline adjustment. I'd say a main challenge was a delayed start due to overlap with prior open project commitments and end of year scheduling constraints. So we learned to add more of a contingency buffer into our projects. In terms of KPIs and challenge outcomes, we met the core technical KPIs, developer focused tooling, modular architecture, and documentation tied to implementation evidence. We delivered the intended milestone outputs, and we made the work publicly accessible through open source repositories. What we didn't achieve was the original delivery timeline. We adjusted the schedule through the formal change process, and we completed the technical deliverables afterwards. One more thing I want to add is just a significant additional achievement in operational continuation. This integration is now running in a preview testnet context alongside our decentralized DNS marketplace, and we're continuing operations without requesting additional funding from Catalyst or the Treasury. So that about wraps us up, and I'll go ahead and kick off the video that demonstrates the outputs and our proof of achievements. Thanks so much.
Milestone 1's goal was to implement parsing and validation of Handshake blockchain data, which we have accomplished. We started with developing support for primitives to handle the blockchain block for the Handshake blockchain format. We have support for blocks and block headers, tests to go with it. We have support for transactions and tests to go with it. We have support for parsing the Handshake transaction output covenant data, which is where the bulk of the useful data that we need is stored. And of course, we have tests for this. We also added support for validation of Handshake proofs, Handshake name proofs. Handshake uses a Merkle tree variant known as Urkel for verifying that a domain exists within the blockchain. This code was ported from the JavaScript and C implementations of this library used in the Handshake ecosystem. We, of course, also have tests. to go with it. These proofs were retrieved from a Handshake node via the API and plugged into our SPV support to validate that it works as expected. We also added support for parsing Handshake block for specific domain data. The various types of covenants contain domain resource data, which we have support for parsing. The domain resource data contains a set of DNS records of a small subset of supported types by Handshake. We, of course, also have tests to go with it. And then here are the tests actually running and passing.
Milestone 2 for the Handshake decentralized DNS blockchain integration with cDNSd project implements network communication with Handshake nodes and generation of a stream of updated blocks. The outputs for this milestone are: develop network protocol code for Handshake, implement block synchronization of Handshake data, and demonstrate the ability to synchronize blocks and process domain ownership updates. Developing the network protocol code for Handshake involved writing code to support the Handshake peer-to-peer network protocol used for communication between nodes on the Handshake network, including things like message encoding/decoding and initial connection version exchange, fetching network peers, and fetching headers and blocks from other nodes on the network. Implementing block synchronization of Handshake data involved adding support for hashing Handshake block headers in order to identify blocks for fetching, refactoring the network protocol for async operation, and creating a framework allowing for continuous block synchronization. Demonstrating the ability to synchronize blocks and process domain ownership updates involved creating an indexer for the Handshake network using the network layer code that we had previously created and processing the blocks that we receive along with their transactions and covenants. We also added debug code, log code, so that we could show the actual processing of these events. Here we can see the debug log output from cDNSd as it processes blocks from the Handshake blockchain. As I pause the output periodically, you can see Handshake domain registrations and updates being processed along with the provided domain resource records.
Milestone 3 for the Handshake decentralized DNS blockchain integration with cDNSd project implements storage and retrieval of Handshake blockchain data, Handshake domain data resolution, ICANN root hints-based resolution, and the ability to fall back from Cardano to Handshake to ICANN when resolving a domain. The outputs for this milestone are: create the ability to store and retrieve Handshake blockchain data in cDNSd, create a Handshake resolver, create an ICANN resolver, implement a fallback from local Cardano to Handshake to ICANN, and demonstrate DNS resolution for domains in Cardano, Handshake, and ICANN. Creating the ability to store and retrieve Handshake blockchain data in cDNSd involved modifying our existing database layer for Handshake support, including things like tracking Handshake domain name hashes so that we know which domain later updates are for, tracking Handshake domain resource data updates for updated DNS records, and tracking Handshake blockchain cursor to resume synchronization after a restart. Creating a Handshake resolver involved wiring up the existing resolver code with our new database query functions for Handshake data. Creating an ICANN resolver involved adding the ability to parse bind style root hints and recursively query them for non-local domains. Implementing a fallback from Cardano to Handshake to ICANN involved addressing some ambiguity in Handshake domain queries, optimizing query code pathways, and cleaning up legacy resolver fallback code that has been superseded by ICANN root hint support. This is a demo of all of the resolvers working together. We start cDNSd, and then we can see it resolving a Cardano-based domain, a Handshake-based domain, and an ICANN domain.